Welcome back to the Pro Mode tutorial series. Today, we'll finally get into scripting with MapleStory Worlds. Scripting provides you with the creative freedom to go beyond what is capable by default and implement your own logic to bring your ideas to life. Let's begin. We've already learned what components and properties are, and so far we've been modifying and playing around with various pre-built components and properties to manipulate our entities. However, in the next couple of episodes, we will begin to learn to create our own components with our own logic and behaviors. So there's a lot of information in these next episodes, so if you're new to scripting, chances are that you may have some difficulty retaining this information the first time around. So we do recommend focusing on obtaining a conceptual understanding of the underlying concepts to begin exploring and experimenting on your own unique ideas, then returning to this video as a reference guide whenever you need a refresher on specific concepts. This video will be timestamped, so please jump to the relevant sections as necessary. MapleStory Worlds utilizes a scripting language known as Lua. However, there are some concepts shared across all programming languages, such that if you learn one language, then it will most likely transfer when it comes time to learn a different language. So before we start diving into the specifics of what MapleStory Worlds Lua unique, let's first begin by learning the basic concepts shared across any programming language. You've likely heard of the phrase, "Hello World," being used to teach new programmers to code. While this may seem rather irrelevant and inapplicable, it's actually a critical part of development. Functions are essentially instructions that tell elements in our world what to do. And the first function we'll learn about here is called the log function. The log function takes in a data type known as a string, which is essentially just a string of characters, and outputs it into our console. It's often used for debugging code, informing or warning the creator of an issue the code has detected. For now, let's simply try outputting a simple string to our console. So we've begun by creating a new project, and my project just contains some basic terrain and a spawn point. And we also have some scripts in here as an artifact of either the template or bringing in some presets. But before we learn how to create our own components and logic scripts, first let's just create a basic script that won't be tied into any components or logic, which means that it won't be able to be attached to any entities or cannot be referenced by other entities and other components in our code. So we'll right click on my desk and go into Create Scripts and click on the Create Script button, and you'll see this kind of settings cog, and we will name this Lua Tutorial. We'll double click to open this script. And scripts will only be run one time at the beginning of our world execution and will not be run anytime after that. And it also, as I mentioned, cannot be referenced or loaded in by other components and logic as well. First, we will begin with our iconic hello world. So the first line of code that we will write is this, and let's break down what's going on here. So first we have the word log, which is the name of our function that we're calling. Log is a pre-existing function native to MapleStory Worlds. So the reason why we can call this function is because it already exists as an element of our library. And if we hover over this, we can see what this function will take in as an argument, meaning what this function will be able to take in as an input to this function so that it can do something. The do something here is that it will output whatever we pass into this log into our console area down below. So in this case, our log function takes in the string of characters, hello world, and it will output that into the console below. So let's just press play and verify that this is actually happening. And as you can see that it has printed the phrase or the string of characters, hello world. Now, the reason we see two different strings being outputted is because one is being outputted to the server side and one is being outputted to the client side. In MapleStory Worlds, we have the concept of client and server when it comes to developing and scripting for MapleStory Worlds, because a lot of our code and a lot of the way that you approach development in MapleStory World will be in consideration for multiplayer synchronization. So when we start learning how to create properties and functions and various parts of Lua and MapleStory World scripting, you'll notice a common theme of having to define whether this code that you've written will run on the client side or whether this code will run on the server side. Because this is just in the scripting file, there will be no distinction between server and client, and this file will run on both the client and the server, which is not ideal, and it's a good idea to be deliberate about these things, but for now and the purposes of learning Lua, we don't care about this. So just to make sure and just to make it easier to visualize, we will select the space and we will uncheck server so that we only see the client-side code. Filtering out the server-side logs doesn't mean that it will no longer run on the server, it just means that we won't see the server-side logs anymore. Going back into our Lua tutorial script, we will stop play. Inside of here, we can write any string we want. So we can type in, this is a line of text. And if we press play, we can see that it outputs to our console just the same. Now a quick reminder that this is executing on both the client and the server, and the only reason we don't see the server-side code is because we're choosing not to see the server-side logs. Let's stop play once more and explore logs a little bit further. Imagine that I wanted to combine two strings together. So we'll say that I have the string I have and another string apples. To combine these together, I will simply use in Lua the syntax of two dots to perform what's known as a concatenation in programming. And this basically just combines two strings together. Let's press play to confirm that this worked. And we can see that it has successfully concatenated my strings together. Now, what is the purpose of this, and why not just have it as a single string? Well, what if I wanted to assign a number to the apples and keep track of how many apples our player has collected? We can concatenate the number 2 to this and say that I have 2 apples, and I can also change my apples out for oranges, for example. If I press play now, we have now split our string into 3 distinct parts: the I have string, the number string, and the oranges string. And in this way, we can have different parts of our string have different purposes. So at the moment, we are still manually inputting the number 2. So we can of course change out this number for 2 or 10 or 20 apples. Now let's actually change our oranges out for apples again. And at the moment, it's still a manual process. We still have to know beforehand that our character has exactly 20 apples. But what if we didn't know how many apples our player will have at the point of this line of code executing? Well, we can use what's known as variables, and variables are space in memory that can store certain data. So if I defined a space in memory to collect the number of apples as our player collects apples, and then our log can then reference our variable to output whatever is contained within that space in memory, and however many apples that has been logged and tracked to be collected at that point in time, we can then reference it and output it to our log. So to do this, we will utilize the keyword local, and we will name this variable apple count, and we'll use the equal sign to assign a value to it. Let's say 10. Then we can switch out the number 20 and use our variable name. Now, if we press play right now, let's see what happens. We get an error saying that it's unable to connect apple count because apple count is nil, or in programming, nothing. The reason for this is because order of execution matters. We have tried to reference the apple count variable before it has even been defined in our memory. So we have to bring this log out after my variable declaration. So now if we press play, I've successfully concatenated the phrase I have and our variable 10, and then apples after that. So now we can just copy this as many times as we want, and then when we press play to output it, we can see that we have 10 apples being printed all of these times. And then to change out our number of apples, we can simply just change the variable, and then every instance of our log will be updated to this new amount. So from 10, now we have 15. So variables are also a good way to make sure that whenever you're referencing this number a lot of times, and if you know that you're going to be referencing this number a lot of times in your code, to have this variable and then be able to change it once instead of needing to change this number out for every instance and every reference in your code. I can change the value of my variable after the fact by simply referencing it in code and assigning it a new value. So let's say my character collected 5 more apples and now we have 20 apples. And let's press play to see what happens. Now, because sequence of execution does matter, and our program is being fed instructions one at a time, line by line, first our apple count is assigned as 15. Then we have 3 logs, each with the value 15. Then we change our value to 20. Then we log again with the new value 20. So down here in our logs, we have 3 logs with the value 15. Then after we change our value to 20, we have the updated log with 20 apples. While you're developing, if you leave your code untouched for an extended period of time, or you leave to work on a different section of your code, when you return to your previous code, oftentimes it's difficult to understand what you were working on. So of course it's good to use descriptive names of your variables and function names and things like that to make your code as clear as possible. But sometimes it's not clear what your intent of your code was. So in this case, it's a good idea to use comments to describe certain things that you were thinking of when you were coding this section of your code. So to create comments, you just use the double dash, and anything after this double dash will be ignored by your program. So if I type in, this is a comment, you can see that there's no complaints, there's no error messages, nothing like that, and I can press play with no problem, and it should log hello world. And you can see that this is true in our console. Make sure that you do remember to place these double dash. If you forget to do that, your script will start to complain about your code, saying that it cannot read it properly. So double dash to make comments. In programming, there are many different types of data that is recognized by our program, and across different programming languages, there's different naming conventions for this data and different ways to approach data. In Lua, we've already learned about 2 different types of data so far, the first being numbers. So we learned how to declare a variable previously, and we used the variable to assign a number type to it. So when we were talking about apples, we have the local keyword to define a variable, and we have the variable name, apple count, and we assign the number value to it. And as we hover over the apple count, it shows a type covered in parentheses as an integer. Now the difference between integer and a number type is that if we were to add maybe like a 2.0, this suddenly becomes a number, because integers do not have fractional components and are just whole numbers. This also, of course, includes negative numbers, but as soon as we add a fractional component like 2.0 or 2.1, then it becomes a number. We'll keep our number an integer type. We can perform mathematical calculations on numbers, so we can, for example, do apple count equals apple count plus 1, which would essentially just add 1 to our current apple count value. So if we log before and after this, apple count, and we log again, right there, it should first print out 2 and then print out 3 because we added 1 to the apple count value. And in our console, this is true. We can subtract, of course, so we can change this plus symbol to a minus symbol. And it will subtract 1 from our apple count. We can divide, so we can change this minus to a division, and we can say divided by 2, which of course would equal 1. And because we added a fractional component to this, our value has been changed to a number type. So keep that in mind as you do certain calculations, that the final value, depending on what kind of operation you're doing, it could change between types. But the number and integer values are relatively interchangeable. We can change this to a multiply. So we can do 2 times 2. And that gives us 4, and this remains an integer. we have shorthand for all of these operations. Instead of doing apple equals apple count times 2, we can do apple plus equals 1. So this is shorthand for apple count equals apple count plus 1. And if we press play now, we can see that it's added, and we can of course do the same thing with the subtract operator. And it's subtracted. We can do the same shorthand for multiply. And for divide. Now, another type of data that we have looked into is the string type. So we can have a variable that we would name how many apples, and we have a concatenation of the string I have and our apple count variable and apples. So after dividing by 2, it should say we have 1.0 apples. It gives us we have 1.0 apples. So with strings, we've already learned how to concatenate strings together, as well as combine them with our variables or different types of number and string literals. A new type of data that we haven't yet learned about is called the Boolean type. And the Boolean type simply holds the value true or false. And this is mostly used when resolving some conditional logic that we will learn about in a future video. So let's learn how this is formatted. We have the local keyword again to reserve space in memory for our variable. Then we have the variable name, have apples, and we have the assignment of the literal Boolean value. When we log this out, we should see the word true outputted onto our console. We can change this to the value false and press play again. And now the console reads false. Again, the main purpose of Booleans is to resolve conditionals. So we will learn about conditionals further in the future. But for example, if I say have apples equals apple count is greater than 2. So this is a Boolean type, and it basically just checks if apple count is greater than 2, which at this point, because it's 1, it should resolve as false, which we can see that this is true. And if I say apple count is greater than 0, and press play now it resolves as true. So Booleans are mostly utilized for conditional logic when you need certain chunks of your code to execute based on that condition. Notice also that the word false, when we initially assigned it, is not in quotations. So this is not a string type variable. This is literally just the literal Boolean value. So keep that in mind, that when you do assignments, that you are not assigning the string false, you are assigning the type Boolean to the have apples variable. The next type of data to discuss are known as vector types. Vector types in Lua hold positional or directional data. Now let's take a look at how this vector type is defined. We have our local keyword again to reserve space in our memory for our variable. We have our variable name, and we've named this variable Bob's position. And we've assigned a value to this variable. Now the way that this assignment is formatted is a little bit different than what we were used to before. When assigning our apple count or our string for how many apples or our Boolean for have apples, it has all been what's known as literal values. Literal values are common types such as numbers, strings, or Booleans. Anything beyond that are custom types specific to the language. So when we define a custom type, we have to tell the custom type how we want to format and structure the type when it's being declared. So when we assign a new vector 2, we have to tell it what the x-coordinate and the y-coordinate is when we define this value. And this is called the constructor for these custom types. In our constructor, if we highlight over this type, we can see that it takes in a float value, which is another name for numbers, of x and y. And for these values, we've passed in 0 and 0. So we are creating a new vector2 with the point 0, 0. So let's try logging out our new vector. And see what this looks like. So we can see that our value is being output to our console as 0 and 0. Let's say that we assign a new vector position to Bob's position. So now Bob has moved a little bit and he's moved to a different position than originally. We can say Bob's position equals vector 2, 1, 2. And this essentially tells our program to create a new vector type of coordinate points 1 and 2 to assign to our Bob's position. So we are creating a new variable to assign to Bob's position. So if we log this once more, we can see that Bob's position starts at 0, 0, and then Bob moved a little bit to 1, 2. Now let's say that we have Jim's position. So we have a new vector type, Jim's position, and we are assigning a vector 3 type. So previously with Bob's position, we've been working in 2D with coordinate values x and y, but Jim is working in a slightly higher dimension in 3D, and he has a z coordinate position within his constructor. So when we define Jim's position, we have to pass in 3 numbers, one for x, one for y, and one for z. And if we log out Jim's position and try pressing play, we can see that we have created Jim's position at position 0, 0, 0. Now, when we modify positional values for our vector 2 and our vector 3 types, we can always assign new vectors as we've done with Bob's position. However, we can directly access each coordinate point individually. So we can say Jim's position dot x equals 5, Jim's position dot y equals, let's say 10, and Jim's position dot z equals 999, because we're working in 2D. And if we try logging out Jim's position now, we will see Jim's position has changed from 0, 0, 0 to 5 in the x, 10 in the y, and 999 in the z. Now, how did I know that Jim's position has certain properties of x, y, and z? Well, vector 3 and vector 2 are custom classes that are contained within our scripting library. So if we open up our scripting API reference, we can search for vector 2. And in the MapleStory Worlds API reference, we can open up this vector 2 type, and we can see that we have all the properties associated with our vector 2 type. We have the x and the y properties, and that's what we've modified. And we can also search for vector 3, and in the API reference, we can see that vector 3 has x, y, and z properties, each associated with the x-axis or the y-axis and the z-axis that we defined in the constructor of our variable. So we can of course do a little bit more interesting things where, let's say we want Jim's x position to always match Bob's position. Then what we can do is Jim's x position equals Bob's position dot x. So remember that we set Bob's position to an x coordinate of 1. So if we press play, we can see that Jim's position matches Bob's position of 1. So when defining vector types, we can utilize the constructor as we've been doing so far by manually assigning the x and y coordinate values for our vector types. However, there are shorthands for commonly used vectors, such as 0, 0, 1, 0, negative 1, 0, things like that. That makes life a little bit easier and makes writing code a little bit faster. So let's look back into our API reference documentation and look at our vector2 type. Here we have our x and y properties that we've looked at previously, and that's what we've been assigning our x and y values to for our vector2 type. However, we also have certain properties marked as static. Static essentially means that this property is shared across all of your instances of this type. And to explain this point, let's go back into our script editor, and we've had Bob's position. But let's say we have George, and George has a position of 1, 0. What we've essentially done is we utilize our type as a blueprint to create a new vector2 position for Bob, and we've utilized the same blueprint to create a new vector2 position for George. However, if we change Bob's position, that does not mean that George's position would now change, because these are instances of our type. However, with static properties, anytime we change one property in one type, all of the instances of that type are updated. So this is basically one variable that's reserved in memory and shared across all of the instances of that type. The way that it's utilized in vector2 is just to have easy shorthands and shortcuts to define common vector2 values. So up here, instead of saying vector2 0, 0, we can say vector2.0. And this would do exactly the same thing as what we had done previously. So let's press play. And we can see that Bob's position, when it starts, is at 0, 0. We have other shorthands, all listed here. So let's print all of the vector2 shorthands. So we can see all of the different shorthands of our static properties for left, up, right, down for our vector2. And again, these are easy ways to define and utilize our vector types. Vector3 has its own set of static property shorthands for 1, 0, left, up, down, but we have 2 more for vector3. Forward and back, because vector3 has a third dimension, and z is the forward direction, and negative z is the backwards direction. So let's press play and take a look at some of these. And we can see for our vector3 types, we have the vector3.1, vector3.0, and all of the different directions. But we also have forward, which is positive in the z, and back, which is negative in the z. The final type that I'd like to go over is known as a table type. Table types in Lua essentially hold collections or lists of data. Imagine an Excel sheet where you have a whole table of data. That's essentially what the table type is doing. So let's learn how to define a table type. In theme with this video, let's define an apples table. And again, we have the local keyword to reserve space in memory for our variable. We have our variable name of apples, and we have a special way to define tables in Lua. When defining tables in Lua, we open and close our table with curly Q brackets, and then we separate each element with a comma. So our apples table holds a list of 2 number types of 2 and 5. To access the elements in our table, we simply use square brackets. So when we try to log out our apples, we would type apples for our variable, and then we would use the open square brackets and close square brackets, and we would reference the number and the index of our element. So the first element is starting at index 1. In many other programming languages, the starting index for these types of data would be 0. But in Lua, we start these lists at index 1. If we want to access the second index, we would of course use the index 2. And if we press play, we should have our values 2 and 5. So if I defined some more variables here, let's say we have a string variable with the string Bob has, and then we have some apples. our first index being 2, and then closing with the word apples. For Jim, Jim has 5 apples, because that's what we've defined in the table. We have the expected value of Bob has 2 apples and Jim has 5 apples. So when we defined this table, we defined it with 2 elements. But what if we wanted to add more elements to this table? So when adding to our table, we have to utilize a special syntax. And we have our table type, which has a function called insert that will take in our table, so which is our apples table that we defined up here, and the new value for our table. So let's say another guy comes along and we want to give that person 30 apples. So let's say this guy's name is George. Because we added a new index with the value 30, to access this new index, we would use the index 3. So George now should have 30 apples. So let's press play. And now Bob has 2 apples, Jim has 5 apples, and George has 30 apples. To remove from our table, we would use the table.remove keyword. And we would pass in the table and the index that we want to remove it from. So our index, in this case, will be 3. And then now, if we try to access our third index here, it shows nil, meaning that George no longer has any apples, and our third index doesn't contain any data. Now, when you're referencing these lists of data, it's a lot easier if you can easily associate different keys to these values. So what we can do is for each of our values in our table, we can assign a key to that value. So instead of accessing them by index, we could access them by the key. So we'll reassign our apples to a new table of Bob, which has 2 apples, and Jim, who has 5 apples. Then, when we access those values, instead of using our index, we would instead use the dot operator to access the key value of Bob, which should be 2, and same for Jim here. And if we press play, now Bob has 2 apples and Jim has 5 apples. We could add a new value to this by simply doing apples.george has 30 apples. And then if we try to log apples.george, now we have 2 apples, 5 apples, and 30 apples. And again, to remove, we can say apples.george equals no. And we'll try to access George's apples one more time. And this time we have 2, 5, and 30. And then finally we have nil because we've removed George's apples. And now George has no apples. If we wanted to clear out our table and remove everything, we could simply do apples and assign it to an empty table. So in this next example, we have a variable apple count, which is an integer value of 1. And I want you to pay attention to these 2 lines down here. What do you think would be output? So in the first line, we have a string literal of 1 being added to our variable apple count. And below that, we have a string literal of 1 being concatenated with our variable apple count. So let's press play to see if whatever answer you thought is correct. So in the first example, we have 2.0, and in the next example, we have 11. Now, why is that the case? Well, in our first example, we have the string literal 1, which is being converted into a number and then being added to our apple count. So this is 1, the number, plus 1. So when we utilize this plus operator, the string literal is being converted into a number before it can be added to our apple count number value. Here, we have the string literal 1 being concatenated to our apple count. So our apple count integer is being converted down into a string value. So the value 1 is being concatenated with the value 1, which is why we have 1, 1. This flow of variables and types being moved between each other to accommodate each other is known as typecasting. And this happens a lot when working with various different types and you're trying to combine and work with them in different ways. Let's take a look at another example. Let's return to Booleans, and let's say that I have a haveApples Boolean variable here. And then we have two logs here. So we have the first log, haveApples, and we have the second log, 1 being concatenated with haveApples. Does this work? Let's press play and see what happens. So the first value is being logged out as true. However, the second log is complaining. It's saying that it's unable to connect haveApples because haveApple is a Boolean type. The reasons this doesn't work is because our concatenation operator is only able to typecast between numbers and strings. It doesn't know what to do with the Boolean type variable. In order to properly typecast our Boolean to a string and have this concatenation work, we first have to utilize a special function, toString. And our toString function takes in any value. So if we have our haveApples variable, this will convert this value into a string type. So now if we paste this in to replace our original line, now this works. It concatenated the string 1 with the Boolean value true. And the reason this worked is because we first converted our Boolean type into a string using a function that knows what to do with Booleans to convert it into strings. So let's take a slightly deeper dive into the concept of functions and how they work and what they do. We've actually already been working with functions quite a bit with our log function and our toString function. Functions at its core is just a set of instructions that's wrapped to a certain name so that we can call and reuse that behavior over and over and over again throughout our code. Functions can either take some sort of input so that it can perform actions on that input. It can also have a return type so that once it's done, it can return some sort of value. Or it can have no input and no output and just perform a set of instructions and be done. So in the case of our log function, we have the function name, which is log, and then it takes in some sort of input so that it can output to the console. The log has no return value, as described by the word void when we hover over the log function. Void just basically is the same as nil, and just means that this function does not return anything. The toString function takes in some sort of input value, and it could be anything. So any is basically an umbrella type of sorts that encapsulates all other types in Lua. So it will take in our Boolean value, for example, and turn that into a string. So as we see in our function description, we have a return type of string. So it takes in whatever value, and then it will return a string value. So we have several other functions that we can take a look at. Let's take a look at this following example with two vector2 types. So we have Bob's position, which is a vector2, and we have Jim's position, which is a vector3. Now, what would happen if we try to add these two vectors together? So we want to add Jim's position to Bob's position. If we try to do this now, it will tell us our console complains that we cannot cast an object of type vector3 to type vector2. And essentially what this is saying is that we cannot add two different types together, and we cannot convert our vector3 type to the vector2 type that we are trying to add to. So what do we have to do? Let's take a look back into our documentation and let's search for vector3. And we can see the API reference here. And let's search for toVector2. So our vector3 type has a conversion function that will convert this current type into a vector2 type. So how do we utilize and call functions? Well, because we're trying to convert Jim's position, which is a vector3, down into Bob's dimension, which is vector2, we can use the colon in Lua to access the functions of a particular type. So from Jim's position, we are trying to access the toVector2 type. So This function will perform a conversion to create a new vector 2 of our x and y coordinates of Jim's position and drop the z coordinate to return a vector 2. And let's press play. So when we log Jim's position, we can see that we have a coordinate of 0 and 1, which is Jim's x coordinate and its y coordinate, and it dropped our z coordinate to turn it into a vector 2. Which is why we were able to add Bob's position to Jim's position to create a new vector of 1 in the x and 1 in the y. So we have more mathematical calculations that we can do with the vector class. We have a distance function where we can calculate the distance between Jim's position and another position. So we have our shorthand for our up vector, which is 0 in the x, 1 in the y, and 0 in the z. And we can calculate the distance between this up vector and Jim's position. So let's see what happens if we do this. We get a distance of 0 because Jim's current position, which is 0, 1, 0, matches that of the vector 3 up position, which is 0, 1, 0, to give us a distance of 0. We can also calculate Jim's position with Bob's position. So if we want to do the distance calculation between Jim's position and Bob's position, which is currently a vector 2, we have to convert this into a vector 3 type. So 2 vector 3. And we know we can do this because if we look into our scripting documentation of our vector 2 class, our vector 2 type has a 2 vector 3 function, which will convert our vector 2 type into a vector 3 type. So we know that this is possible. So let's press play now. And this gave us the distance between Jim's position and Bob's position. We can also do something like this, where we can take a cross of Jim's position and Bob's position, and take the cross product to give us a perpendicular vector. We are currently assigning Jim's position to vector 3.up, and Bob's position, which is still a vector 2, a vector 2.right. Now, when we try to do the cross product of Jim's position and Bob's position, again, because Jim's position is a vector 3 type, we have to convert Bob's position to a vector 3 as well. So now, if we copy and paste our final value and try to output, we can see that we have a final cross product of 0, 0, and -1, which is the correct answer of if you did the cross product of 0, 1, 0 and 1, 0, 0. So far, we've been working with functions that are pre-built into the MapleStory Worlds Lua language, such as log and toString, as well as functions that are built into the different types. However, we can define our own function with their own set of behaviors. So let's take a look at the syntax of how to define a function. So to write your own custom function, we use the function keyword to define the start of the function and the end keyword to define the end of a function. Then we write the name of our function, which is say hello in this case. Then we use the open and close parentheses to define the parameters or the input to our function. In this case, we will have no parameters, but we still need the open and close parentheses. And then we have our function content or the function instructions. In our say hello function, we are simply going to print the iconic hello world out to our console, and we will call this function by simply writing the name of the function and defining our inputs to this function. In this case, we have no inputs. Let's press play and see that this works. And you can see that we have hello world being output to our console. We can also define a function with certain parameters. So consider this function. We have again, the function keyword with the end keyword to define the end of our function. Then we have our function name print position, and we have our input parameters of name and position. In this case, we are again using the log to output to our console, and we are going to output the name, which is going to be passed into this function and be printed. This value is going to be concatenated with this string literal here, and then at the end be concatenated with the position value. To call this function, we will define two position values. So let's bring Bob and Jin back in again. Bob has a position vector of vector 2 of 1 and 0, and Jim has a position of vector 3 of 0, 1, and 0. Then we will pass in Bob to our print position function, and we will type print position, and we will say Bob as the name, and we will pass in our Bob's position variable as the value. You can do the same for Jim. And let's see what happens if we press play. Now we got an error. Can you guess what the error is? As we mentioned before when we were talking about concatenation and typecasting, when we concatenate a literal string with a position value of vector 3 or vector 2, we cannot convert automatically between string and vector. So we have to first manually convert this into a string before we can concatenate this with our string literal. So we will use the toString function again to change our input value into a string literal, and then press play once more. And now we can see that our position values are being logged properly. Bob's position is 1 and 0, and Jim's position is 0, 1, 0, which is the proper position values. Now, you might say that it's really not that hard to write out these functions and have logs repeated a bunch of times instead of having to write this whole function out. But when it comes to programming, it's a good practice to separate out code that you know may be repeated over and over and over, because let's say our print position value is going to have longer behavior. So let's say that we have to add more position values to this function, or later on we need to change the parameter value so that it outputs more. Then it's a lot easier to just edit this function and its behaviors rather than to go and search for every single instance of our log throughout our code. So wherever you can and wherever you know that there will be repeated code, it's a good idea to separate it out into your own function so that you can just simply call it. Let's look at one more example, this time with a return value. So we have a function here, sum, with the return value. So we have again the function keyword and the end keyword to end the start and end of our function. We have the function name of sum, and we have the input parameters of a and b. Then we have this keyword, which will return the sum of a and b. So we have a return value from our sum function that we can use later on in our code. So consider that we have this log. We have the string literal, the sum is, and we are concatenating that with the return value of our sum. So we can call the sum function, pass in some numbers, let's say 1 and 2, for 1 for a and 2 for b, and our function is going to return the sum of a and b. So here, this should return the sum is 3, and this won't give an error because we know that concatenations will automatically convert between numbers and strings. So if we press play, we can see that this works. The sum is 3. Let's say we have variables, a and b. So a is 5 and b is 10. We can have a third variable, sum, to hold the value of sum, and then we can print out the value. So we can assign the sum value to the return value of our function. So our sum function is going to take in the input parameters of a, which is 5, and b, which is 10, add them together and return the final value. So our final value that's stored within our sum variable should be 15. Pressing play, we can see that this is true. That's everything that I have for you in this episode. Thank you so much for joining me in today's video. Hopefully we've provided you with the conceptual understanding of the basic building blocks that make up any programming language. Today we've gone over data types, variables, tables, and functions. And next time we'll take a deeper dive into the conditional and looping logic to start adding a bit of complexity.